module 3 today or module 2 today. A test. So there's a test on module 1 and 2. That'll be on Cisco, out of Cisco Academy. I'll make sure that's turned on. I don't think it's turned on right now, so I will make sure it's on. Test 1 on. I'll verify that. And it's due 31st. So there's packet tracers, 3 packet tracers, and that exam is due, or the test is due for module 1 and 2 on Sunday. All right, everybody good? So let's go ahead and get finished with this thing. Okay, so we're talking about OSPF. OSPF, true or false? Is it a linked state routing protocol?
True.
True.
True. Excellent. It's true. Okay, and so as these routers come up, what are they sending out to the other routers when they come up?
Hello packets?
Yeah.
Hellos.
Yeah, they're going through hellos, going through a series of steps before, and once everybody gets their, using these LSAs and all this kind of stuff, links, state advertisements. Once they're sending and receiving this information, they build this database, and then they go through an algorithm and find the best path to get someplace, that type of stuff. And once all of that is finished, we go to what they call a converged network. It's converged, and that's what's also that last state is full. So you'll see that here today, is you can see where everything's already. Everybody's talking to everybody, knows what's going on and all that, and when it moves into that full state. So OSPF network types, point-to-point, broadcast, different things going on there here. But what I want to kind of draw your attention to is this, and we talked about this Tuesday. So remember when there was a formula that was used that in this example here, we've got what, 1, 2, 3, 4, 5. We've got five routers out there that's sending all these commands out. So if we're sending our information, our hello packets to everybody in that network all the time, and keeping everything updated, how many, with 5 routers, how many or how much communication is going on there? So how many devices, or how many times are these commands going out there? Remember that command, it was n minus 1 divided by 2. So we've got 5 times 4 divided by 2, which is 20 divided by 2, which is 10. So we're talking to 10 different routers. So this is for 5. So all that communication is going out there. That puts a lot of unnecessary traffic out there. Plus you've got all of these, your resources that are being utilized, your processor, your memory, all that kind of stuff. So to help with that, what is created is something called a DR and a BDR. You remember what that DR was called, what it stands for?
Designated router?
Yeah, it was the designated router. And then you have the BDR. What's the BDR?
Backup designated router?
It's a backup designated router, right. So what happens is, as we start sending these hello commands out, what's one of the first things they start doing? They start figuring out, okay, who's the DR, who's the BDR? And how do they determine that? What's the first thing they look at? Do you remember that? Remember the first thing they look at of who's the DR, BDR?
The router ID?
Is
the priority. It looks at that priority first. And remember, priorities went from 0 to 255. By default, what are they? What's the
1?
Exactly. So all routers by default have that priority of 1 for the OSPF priority. So if they're all 1, then they're all equal. So the higher the number, all the way up to 255, so the highest priority number is going to be the DR. The second highest number would be the BDR. Okay, what if I made it a 0? What was that? I think we mentioned that. What was a 0?
That was the static setting.
Well, 0 means that it's not, I'm not going to participate with this. I'm not going to participate. So it's not going to make it it's not going to put it in contention to be either a DR or BDR. Okay, so that's the first thing it looks at. And then that's known as a druther or a DR other. Okay, so if I'm not a DR and I'm not a BDR, then if I'm neither one of those, then I'm a druther or DR other. Okay, and you can force it to be that by making it a 0. All right. So initially, when these routers are turned on, they're turned on, and then they go into this init state. And then you remember what multicast address they were broadcasting out? The multicast address they were broadcasting out was 224. There it is, right there. 224.0.0.5. So that's going out to everybody. Okay. Once that goes out, and we decide who is the DR and who's the BDR, then it's going to send out, the routers are going to send out a multi-broadcast to 224.0.0.6 to that group. Well, when it goes to that group, that's going to your DR and your BDR. So that's what this is showing here. So check this out. It's real quick. So here's my LSA. Remember those LSA, it sends and it receives that. That's what is being sent and received to let the other routers know what's going on. It goes out, and notice it went to just the DR and the BDR. Okay. The reason it did that is because it knows that there's a DR and a BDR. So I'm not going to send this to, in this example, we ran the calculations and it says 10. I'm not going to send out all this traffic everywhere. I'm just going to send it to these two places. They're like the master or the primary and the backup. So it sends it there. Now, once it gets here, watch what happens, because the DR designated, right? He's in charge. So watch what he does. He's going to turn around, and where do you think he might send it? The information back out to these other routers. He's going to send it to all of them because he's in charge. So here he goes. He sends it out to all of them. And boom, there it went to all of them. Okay, so that's updated. So as you see, as it sends this multicast out, it sends that multicast out. Once it knows, each one of them will do it. Once it knows, it's going to send it to the DR, to BDR, and if the DR is still in control, then it will send out to everybody to update them. Okay, that's how that's flowing. So here's a topology here. So let me ask you this question. So looking at this topology, router 3 is the DR. Okay, and router 2 is the BDR. What made router 3 with the information that we have here? What made router 3 the DR and router 2 the BDR?
The router ID.
That's exactly right. So the first thing it does is it looks at that priority. 1 to 20, well, 0 to 255, but 1's default. If everybody's 1, the next thing it looks at is the router ID. It picks the highest router ID. Okay, you're the designated router, and then the next highest is going to be the BDR. Exactly. So this is just talking about how can you tell, looking at the roles that they're in. So here they're on router 1. So right here they're on router 1. So if you're not a DR and you're not a BDR, what were you called? What's your role in this thing? What's your role in this thing? What are you called? If I'm not a an OSPF world, if you're not I got you, Chris. If you're not a DR or BDR, what are you?
The DR other?
Yeah, that DR other or druther. That's right. Or if you made that priority as 0, you're going to default into that. So let's look at this. So R1 is, and we can see what it is. So look on R1 here. They did a show IP OSPF interface gig 000. So what I'm doing is I'm looking at this interface right here. There's my interface right there, because that's what's tying us over there. So look what it's telling us here. What they have highlighted, state. It tells us, okay, this is the state we're in. We're druther here, a priority 1. Well, if it's priority 1, nobody changed that, so by default it's priority 1. And it says the designated router, it knows it at 333 where the address is, and it knows the backup router as well. Okay. And so it's looking for its neighbor. It sees 2 neighbors and 2 adjacent neighbors out there, and it sees them there, 222 and 333. So you can see here, these are neighbors. Okay, they're directly associated or adjacent to it there. All right. Now look at this. Here's R2. What is R2? Is a BDR. So looking at it, router 2, we're doing show IP OSPF interface G0/0/0, which is this interface right here. Okay, look at that interface, and it comes back and it tells us the state. Oh, this is a BDR, the priority of 1. So obviously nobody changed that. The DR is 333 where he's at, and we can see the backup. This is us, really. There it is. And we can also see the neighbor count of 2, and it sees router ID 1.1.1 and 3.3.3, which is, you can see them right here. That's its neighbors associated with it. And last but not least, we have the DR. Same command here on router 3. We're looking at the IP OSPF interface. And from there, we can see it's a DR. There's a priority. So since all 3 of those had a priority of 1, they're all equal. The next thing we look at is, let's go to the highest router ID. That will be your DR. And you can see right there that it is definitely our DR and then our BDR. So pretty straightforward stuff right there. Okay. So everybody sees how you can go in, you can verify what they are, and that kind of stuff. Verify DR, BDR adjacencies. So here's what I was talking about. So here's the 2-way. Remember when we went through the states? Here we go right here. So remember these states? We went init, 2-way, EX start, EX change, loading in full. So these, you remember, as we're sending these, these LSAs are going out, we're sending and receiving information. We're building this database, or we're figuring out the best route to go, all of that kind of stuff. Once all of that's completed, we're in the full state. Okay, so that's what they're talking about here with this being full, and you can also notice the 2-way state there. There's where that one is right there. Okay, so you can see here, full druther here. This is a DR. BR is fully adjacent with non-DR or BDR router. So we can see the different states there. And how can we view that with the commands? Well, it's basically show IP OSPF neighbor. This is kind of like, remember show CDP neighbor? CDP is Cisco, what is it? Cisco Discovery Protocol is what it stands for. Neighbor. Well, this is kind of something similar to that, where this is saying, okay, I'm on router 1 and I'm typing in show IP OSP neighbor. I want you to go out and I want you to tell me the neighbors that you're associated to. So if I'm on 1, it's telling me here's my neighbors 222, 333. Both had a priority of 1. They're both all, they're all the way up. They're converged here, and one's the BDR and there's the DR. Same thing if I go to router 2. So you can see how that command right there is a real helpful command to show, the state and who the neighbors are, what state that neighbor's in. So the selection process, so we've kind of been talking about that. How do we elect it? We've mentioned this. The priority is between 0 and 255. By default, it's 1. If it's a 0, it's saying, hey, I'm not going to participate in this DR or BDR BDR election. I'm not going to participate. I'm just going to be a druther here. Okay. So it won't participate and it becomes a druther. The default priority on multicast is 1. So we mentioned that. And then if you want to assign one based off of priority, you give it a number between 1 to 255. Okay. Then it's going to look at the router ID, see who's the highest. After the router ID, the next thing, if you don't have that defined, in this case, you can see them defined. If that's not defined, the next thing you look at is the loopback. If there's a loopback address assigned, it's the highest loopback address. And if that's not defined, then it's going to look at the highest IPv4 address. Okay, the highest IPv4 address. So if you were looking at this example here, for example, if they're all priority 1, so we know it's looking at the router ID. If it didn't have the router ID, I don't see a loopback here. So then what would be the next thing that it would look at?
The IPv4 address?
Yes, it's that IPv4 address. So when it looks at that IPv4 address, let's look at that. Let's say we're keying off of that. Okay. So if we're keying off of that, what would be the designated router based off of the highest one?
Router 3.
Router who?
3.
Would it be 3?
R3.
Which is higher? Well, actually, we can't see. I can't see.
3.0. Yeah.
Well, no. These are networks over here. I don't know what this network is. 192.168.1.0. So it depends on if router 3 was say .254, that would be the highest. But if this was 254, it'd be the highest. So yeah, we don't have enough information to base that off of. Yeah. So that was a bad question. I should have thought about that before I asked it. That's a bad question.
I forgot.
So the 172 is the gateway address.
This is the network over here, it looks like. Because see, this is a switch, right? If this is a switch, these all have to be on the same network, aren't they? It's a layer 2 device. So if these are on the same network, this is that network. The 172.16.3, it would be this network out here off of this interface. This network here would be this interface's network, and then this 172.16.1.0 would be this network off of this interface. Yeah, so there's not, so this network here that these are all interconnected with is 192.168.1.0. So we don't know the actual address of who's who here.
Hey, Mr. Carson, I'm sorry I'm late. I completely forgot to set an alarm.
I got you. I got you. And Chris, I got you as well. Okay. So there's the topology there. Okay, so now failover with these guys. Okay, so let's look at this. So in this example right here, if I'm looking at this, so we have elected a, so this guy here was well, man, let me go back up here and look. Okay, here we go. So see, router 2 was the BDR, router 3 was a DR, and router 1 was a what?
DR other?
Yeah,
The
just a DR other, just a druther there. Okay, so let's go down here. Okay, so now in this example here, what has happened is who failed? Who just went offline?
R3.
R3 just went offline. R3 goes offline. He was the DR, right? So what's the purpose of the BDR?
Redundancy.
Yeah, redundancy. So now my DR went offline. I'm the backup designated router. And so what do? I'm now elevated to the DR. So now I become the DR. And then once that becomes the DR, guess what? We go through an election period to find out, okay, who's the next highest priority? If it's not the priority, I'm going to look at my router ID and say, oh, here's my next router ID. So now you are now the BDR. So see how that happens? And the way this is happening is because remember that that hello command? We send that hello command out, say by default is 10 seconds. Every 10 seconds, that hello command is going out. Well, if I don't receive a hello command within within 10 seconds, well, let me back up. If I don't receive that by time a dead man timer goes to 0, then I'm going to say, oh, that guy's offline. And by default, that's 4 times the amount of the hello command. So hello command's 10 seconds by default. 4 times, which would be 40 seconds by default, is a dead man timer. So if I don't receive some notification from you within 40 seconds, you're offline. So this guy goes offline, and then that backup, he now is elevated to the DR. And then an election goes on. It says, okay, now the next highest priority, the next highest router ID, you know, whichever one that is, it is now goes to the BDR. Does that make sense? Y'all see how that works?
Yes, sir.
Okay. So let's look at this. So now router 3 comes back up online. Well, when 3 comes back up online, we've already done this election. We've already done the election. This guy, router 2, was the designated router, and number 1 was the backup. And so when this guy comes up, number 3 comes back online, he comes up as just a druther. So it's not going to say, hey, I have a higher than you. You know, I'm going to take it from you. You need to go down, that kind of stuff. That's not going to happen. What's going to happen is everything stays in that same mode until something happens. Now, so that's what's going on. Let me see if see what this next one does. I can't remember. Okay, so here they bring another one online. Okay, so router 4 comes online. Look at what router 4 comes up as. He comes up as a druther. Why did he come up as a druther? Even though he has the highest router ID. Why did he come up as a druther?
Because the DR and BDR function normally.
Yeah. The DR and the BDR function normally. We've already had this election. As long as nothing changes, we're not going to strip them of that title. So that's why that guy came up as a as a druther here. Now look at this. Now router 2 fails. When router 2 fails, who was the BDR over here? So see, router 2 is a DR. Router 1 is the BDR. So if router 2 fails, who's now going to become the BDR? I mean the DR.
R1?
4.
No, router 1. Why is router 1? Router 1 will be because he's the BDR. You know, kind of like president, vice president. If the president, you know, bites the bullet, or, well, that's a bad phrase. If he croaks, you know, something, or is incapacitated, let me say it that way. If something happens to the president, who steps up? The vice president. So we're not going to go out and do another election. We're just going to bring the vice president, elevate him up. So that's what's going to happen here. So this guy fails. This guy, router 1, is going from a BDR to a DR. Now we got to do an election because we need a BDR, right? So what's what happens here? He fails. This guy, he goes to DR, even though he's the lowest one on the poll right here. But he was the BDR. Now he goes to the DR. And now we're doing an election for a BDR. Okay, well, these two guys are the only people in the running. Who's got the highest priority? Oh, they're the same. Who's got the highest router ID? Well, router 4 does. Okay, router 4, you're the BDR. Okay, does that make sense? Once you have a failure, that BDR steps up to the plate. Then another BDR becomes a DR, and then there's an election for the BDR. It's going to look at everybody. Okay, puts that person in that position. If that DR fails, then that most recent BDR is elevated to the DR, and you do another election. And it doesn't, you know, once it comes back online, it'll come back up as a druther. It doesn't force another re-election there. Okay. So everybody's got that, right? That makes sense? Makes sense?
Sure.
Pretty straightforward there. IP OSPF priority command. So here's that priority, you know, talking about it. If we want to change that priority, we give it a number of 0 to 255. By default, it's 1. And we've mentioned this before. 1 to 55, you know, puts it in contention to be a priority. If you make it a 0, it's like, oh, I'm just going to say here, I'm never going to participate as a DR or BDR. I'll always be a druther there. So you can see the command right here. Router 1. We go to that interface. Why are we going to that interface? Because this is the interface that's out here. And then we're going to change that priority by the command of IP OSPF priority 255. So that's the highest priority we can have. So that right there would put him in contention to be the DR unless something happened to him. And then here's given a priority of 0. Like, so if after I executed this command, would router 3 ever be a DR or a BDR?
No, sir.
No, it'll never be a DR BDR because we made it priority of 0. 0 says, hey, we're not participating. So the following command shows how to clear the OSP processing on router 1, and it's clear here, and then you it gives you confirmation. Whenever you see like this example right here, when you see no in bracket or something in brackets, that's the default, where if you just hit enter, it would be no. They type Y to see yes. So anytime you see brackets like that, that's kind of the default of what they're going to do. So here you can see they went in, they cleared it, and once they cleared the OSPF process, Did you see it? And they did a show the IP OSPF interface. You can see that it came up with a priority of 255 as the DR. All right. Any questions on that? So let's take a look at a couple of these commands here then. Use the IP OSPF priority command to change the DR and BDR as follows, okay? Router 1 should be the BDR and will be configured with a priority of 10, okay? R2 should never be a BDR and will be configured with a priority of 0. And R3 should be the DR and will be left with a default priority of 100. Okay, all routers use G/000 for the interface. Okay, you are logged into router 1. So I'm in router 1 in global config. Where do I have to go first to set this command up? I got to set the priority to 10. First thing I got to do is I got to go to that interface. So I'm going to go to the interface, G0/0/0. Now I'm in that interface. Now I want to set up that priority. So it's IP OSPF priority. I hate you gotta type all this stuff out. Makes me, I'm lazy with the commands. So priority of, what's the priority is 10. What's wrong with that command? PIOR. That's my phone ringing. I'm ignoring it. That's right, isn't it? Okay, there it is. So now, so we got that set. We got this first step set right here. Now, the next thing we got to do is we want to set up priority of 0. So in router 2. So he's not going to participate. He's not going to be a DR or a BDR. So we got to go to that interface. Because again, that interface is, these interfaces here is what's, it's what is G00 on all of them right here. It's in this section here. Interface G0/0/0. Boom. Okay. So now we've got to do an IP OSPF PRIORITY with 0. Okay, we've got him set. Now we're in router 3. We've got to get it set up with a priority of 100. Okay, so that was going to be the backup domain, I think is what it said, wasn't it? So it's interface. Got to get in that interface. We're in that interface. Now we're going to set up that priority. OSPF. What does OSPF stand for?
Open shortest path first.
Yep. 100. Oh man, OSPF. What's wrong with that? PRIORITY. If I could spell it, it'd be dangerous. Okay, what is this saying here now to us? You are still logged into R3. Return privilege exec mode because R3 is to be DR and restart it. So how do I return back to privilege exec mode?
End.
Yep, I go end. What would an exit do?
Take you to global config.
Yeah, just take me back one step. So I'm going to go in. And then what does it say do here? It says return privilege because R3 is to be the DR. Restart the OSC process first. So how do we do that? Clear IP OSPF process. And it says reset. It defaults no. I said, no, I do want to reset it. So I'm going to put yes in there. Boom, there it goes. Okay, now we are logged into R1, privilege exec mode, and restart this guy too. So, we won't need to do anything because we're already there. So we're going to do a clear. OSPF process and clear him, and also the remaining one here. Clear IP OSPF process. All right. So what is this saying here? You are now logged in R1. Use the show IP OSPF interface G00 command to verify that R1 is the BDR. So show IP OSPF interface G0/0/0. Man, that's a lot of typing. Okay, so we come up here. So here's a command we typed in. Where do we see that? I'm right here, because we're verifying this to the BDR. Right here we go. State BDR. There's the priority of it. You can see our other information here. Who's the backup? All that kind of stuff. Right. So R2, what does he want us to do? Log into R2, do the same thing. Show. Whoops. Show IP OSPF interface. Same thing here. We go up here, we can see it. It's a druther, priority 0. Anytime it's a 0, that's what it's going to be. And router 3 here. All right. Anybody got any questions about that? No? Everybody good?
Sir.
All right.
We good?
Pretty straightforward there. Here's a packet tracer. You can do that if you want to. I didn't put it on there to be done. But if you want to do it, it has you step through and where you can see the you can see those changes in the packet tracer. It's not necessary. Okay, cost, OSPF cost matrix. So the cost matrix is based off of a formula. So cost equal, and cost is a route it's going to pick. Okay, this is, remember when we talked about that Dijkstra's algorithm is the algorithm it used here for how we're going to route through, you know, and it's the same as like a GPS. And remember where we said, like on a GPS, it's going to give us the fastest route, and the way it's going to give us that fastest route is looking at the roads you're traveling on and knows the speed limit. It knows interstates are 65, 70s, back roads 35, 45, whatever they might be, and it can kind of, it goes to an algorithm and comes up with, okay, if you go this route, that's the fastest path. Well, this matrix is the same thing, where the matrix is, it's going to look at each of your interfaces. If this is a, you know, of your interface and what the bandwidth is, and it's going to come up with a cost associated with that. So, and it adds it up as cumulative. So if I'm going from this router to this router, that's a cost. From this router to the next router, that's a cost. So I'm adding it up. So it's all cumulative. And ever who has the lowest cost, that's going to be the route I take, or that matrix, cost or matrix, kind of use interchangeably there. So how is this cost calculated? Well, by default, it's the reference bandwidth divided by the interface bandwidth, okay? But you can run into some problems with that. Here's the problem you can run into. For example, if you look at this reference bandwidth here of 100 meg right here, okay, if this is 100 meg bandwidth and that's my reference on all of them, well, look what you do. It's reference divided by interface bandwidth. So here's the reference. See, the reference stayed the same, but this 10 gig line, so it's divided by the bandwidth. There's 10 gig. that comes out to 0.01. Okay. Look at gig Ethernet. There's a gig, so we got reference bandwidth, which is that 100 meg divided by a gig is 0.1. So in this example right here, 0.01 or 0.1, who's lower? Obviously the 0.01 is lower. But here's the problem. When it does this calculation, it only uses integers. So it has to be a whole number. It can't do fractions. It's got to be a whole number. So 0.01, guess what? It rounds to 1. 0.1, it rounds to 1. And then here's a fast Ethernet at 100 meg. It's 1. So wow, look at these three right here. All three of these have the same cost or the same matrix of 1. So that's a problem for us. Okay, so what we can do is we can go in and adjust this reference bandwidth. If we adjust this reference bandwidth, that's going to change this outcome over here. So, here's how, so looking at this example here, so now we have changed our reference bandwidth to, what have we changed it to? That's a big honking number, isn't it? That's 10 billion, right? What is 10 billion? 10 billion is 10 gig, right? Let me show you this, just as a refresher or reminder. Let me hit clear. There's clear. So look at this. So I'm gonna write this number down. 10 0 0 0 0 0 0 0 0 0. Okay, remember kilobytes equal 10 to the what? What's kilo? 10 to the what?
1,000.
It's 1,000, so it's 10 to the third, right? Which is really this. I got 3 zeros out here. Mega is what? 10 to the what?
6.
6, that's right. So I've got 6 zeros. That's mega. A gigabyte, which is billion, right, is 10 to the what?
9th.
9th, that's right. So I got 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So how many zeros we got here? There's zeros. 3, there's 3, there's 3. Wow. So we can take and do this. We can substitute those 9 zeros with a gigabyte, and we'd put this right here. There's your 10 gigabytes or 10 gigabits. See how we did that? Does that make sense? That's probably a refresher, I hope. So so you look at something like this and it's like, oh crap, but you start whacking away those zeros, like, there's your 10 to the 9th. So there's your gig right there and that. So here's my point with this. So now 10 gig is our fastest connection we got on this network. If that's the fastest connection, then I have to go to every single router, and make my reference bandwidth just right here. Now look what happens. My reference bandwidth is 10 gig divided by my default bandwidth, which is my interface right here. So 10 gig divided by 10 gig is 1. Look at this. Here's a gigabit, 1 gigabit. Okay, there's my reference bandwidth, which is 10 divided by a gigabit. And so remember, there's my 9 zeros. So I can replace those 9 zeros with a G. So there's 1 gigabit. 1 gigabit equals 10. Fast Ethernet, you can see it here. There's 6 zeros here. I'm going to whack out of the way, and I'm going to make that in mega. So see, 100, there's my 100 megabits. It's 100 and 10 Ethernet. So now this is very clear, isn't it? If I got a 10 gig line, my cost is 1. Remember, that lower the cost, that's the way we want to go. I got a 1 gig, it's a 10. If I got 100 megabits or fast Ethernet, it's 100. And if I got a 10 megabits, it's 1,000. So, that by default, that formula, it's always reference bandwidth divided by the default bandwidth of that interface, the speed of that interface. And you want to make that reference bandwidth high enough so that your highest link, so that you don't get fractions, because if you start getting fractions, it rolls it up to the next whole number. And you can see in that example, the example we showed right here, how these three here, the metric would be the same. And there is a huge difference between a 100 megabit link and a 10 gigabit link. Huge difference. So here they're just showing the cost. So that's that. You can see the cost of it right here, and different interfaces there. Okay. It accumulates. We talked about that, where it builds that cost. So if I'm going from this right here to over here, I've got to figure out this cost. I've got to if I go this way, the cost this way is 10, cost this way is 10. So there's 20, and then over here 21. Or if I just went from router 1 to router 3, the cost is 10. That's the way I'm going to go this way. So it builds that cost. It's cumulative. It accumulates it the entire way. So looking at this, a couple of things. They did a show IP route, and they piped it through just to see this right here. So let's look at this. What does this O mean right here? Do you remember that? That's in a legend. If you do a show IP route, you'll see that. What is that O?
OSPF?
That's exactly right. It's OSPF. Good job. What was this 110?
The administrative distance?
That's right. That's the administrative distance. OSPF, the administrative distance, is 110 for OSPF. It changes for different routing protocols. And this 11 is the matrix. That's the cumulative of how it built up. Okay. So here's 10 and a cost of 1. So that's where it's getting the 11 at right there. All right. See the same thing here from a router 1, and this way OSPF a 20 is cumulative to go out this other interface. It's going to cost us more to go that way. So it's going to pick that shorter cost. Here's the interface, putting a cost here. If you place the cost in there like that, and give it on the, also putting that, if you put that cost on the loopback address, and you can see here how that changed it. Oh, test failovers 246. Okay, so let's go ahead and do a problem here. Well, not a problem, but I guess it is a problem, isn't it? Go through the syntax on this. So you are logged into R2 using the interface name LO0, which what is LO0? What does that mean to us?
A loopback?
Yeah, loopback 0. That's loopback 0. It's good to use loopbacks on routers because the interface, it doesn't matter if you don't have to turn it on or anything. That interface is always up and ready to go. So anyway, use the interface name to set the cost value of the loopback interface to 10, return to global configuration, use round tables to show IP route. So the first thing we need to do is to go to, we're in global config, is go to that interface LO0. Now, once we're in that interface, it wants us to do the cost of 10. So it's IP OSPF cost, and it is 10. And we want to go, okay, we got to do the other one. We can't do it in global config. Actually, you can do that if you can't do it in this emulator here, but if you're on a real system, you can type in the command do. If you're in like configure something like that, you can type in do, and I could go in this example here, I could go show IP route OSPF. That's what they wanted us to do right here, right? But it doesn't work on this. So what I have to do instead of doing that is I'll do an N to get me back to here, privilege exec, and then I'll type the command. But that do command is real handy where you don't have to come all the way out of this thing. It'll launch it out. Has anybody ever used that?
I have.
Yeah, I think they've shown it in the lab because it's pretty handy to use that if you're setting up in configuration mode and you don't want to go down and come back up. Just do a do command and it'll execute it. Okay, so now we're so looking here. 10 cost NOSPF. So set it up. So here, let's go in and what does it want us to do? The cost value to router 3. LAN 11 because loopback is still reporting a default of cost of 1. It says you're now logged into 3. Use the interface name L1, go to that interface. Okay. So what's the first thing we got to do here?
Go to the loopback interface.
Okay. So if we go to loopback interface. Oh, crap. LO0. Okay. And what do we do next here? We're going to set that cost to what? 10.
10.
So SIP OSPF cost 10. All right. And then it wants us to go to interface name G00 and set the cost value of the link R1 to 30. Okay. So interface G0/0/0. And once it says cost 30, OSPF cost 30. Okay, and what's the last thing? Return to privilege exec mode. Verify the round table entries. How do I verify? What's the command? Well, if we're verifying something, usually it's always a show IP. It tells us here route OSPF, and here we can see it here. So when you're verifying stuff, this is what you're doing. And that's it. Okay. So let's going through and modifying cost or the metrics. Hello packets. Remember those hellos are going out there when they're first, starting up, and then it's going to send stuff out to your DR and BDR. Let it know that things are still up and going. And your hello packet. And here's right here. See, I mentioned this earlier. If it's going out to every router, it's at 224.0.0.5. If it's going to that DR BDR, it's 224.0.0.6. Okay, and by default, that hello is 10 seconds. Okay, 10 seconds. Hello, I'm still here. Hello, I'm still here. And then remember that dead man timer. It is set for 4 times by default. It's 4 times of what that hello is, so it's at 40 seconds. So if I don't hear something within 40 seconds, then we're going to assume he's off. And here they're talking about that. And so, you know, if it goes off and if it happens to be the DR, the DR goes off, then the BDR is elevated to a DR and we do an election for a new BDR. If the BDR goes off, the DR stays there and it does an election for the BDR. Okay. So here you can see, looking at that interface, that gig interface is pointing out running OSPF. There's our hello command. By default, it's 10, and you can see the dead man timer here. Okay. Here's your neighbors. You can see your counters there decrementing. So here they're going in and they're changing interface. They're changing the hello interval to 5 seconds, and they're changing the dead interval timer, dead man timer, to 20 seconds here. So it's going to send out the hellos more frequently. And if something happens, you're going to know it. You're going to know it faster. And what, you know, this is one of those dynamic routing, going back to OSPF again. OSPF is a linked state and it's dynamic routing. So if traffic fails one way, then we're going to start routing it the other way. Just like if I use a GPS, if I'm on the interstate and let's say there's an accident, a lot of GPSs now will get updates on them where it routes you around that traffic. Have y'all seen that or experienced that? I think Google probably does it too on your phone. Have you ever seen that?
Yes, sir.
I'm pretty sure Google does it.
Yeah, same type thing here. So that algorithm's running. It says, "Oh, this is no longer the fastest route because there's an accident and I'm going 0 miles per hour or 15. So let's get people off of this, divert them around this place, and then pick back up." That's what happens here. Is if a router goes down, it's going to recalculate and route traffic a different way. And here, you know, just changing your intervals right here. So this is going in and modifying the hello and dead intervals. Pretty straightforward here. You're logged in R3, enter the show ISPF neighbor command to see who's adjacent to us. So we're going to go show IP OSPF NEIGHWR. Okay, so I can see here. No results are returned. Oh. No results returned for Jason. You are now in the global configuration mode. Okay, use interface G000, name and configuration hello command, matches R2, interface configure. Okay, return for. Okay, so first thing we gotta do is gotta get interface G000. Interface G0/0/0. We're on that interface. Now that we're on that interface, what are we doing? We want to change that hello command to match R1. What was R1? It was 5 seconds is what they changed it to, wasn't it? IP OSPF hello interval interval. Man, typing these full commands out kill me. It was changed to 5. So okay, there it went. And now what's the next thing it wants us to do is go to the next interface and G01. And we got to change that one as well. IP OSPF hello interval. 5 seconds. I mistyped that. When somebody catch that? Okay, now he's up. Now what does it want us to do? Return to privileged exec mode. That's an end. And view neighbor adjacencies. Okay, show IP OSPF neighbor. I want to stop here because that's all you need to do. VOR. There you go. Okay. So I can see my neighbors there. So hello and dead interval timers. Packet 211. That's one 2411. You got that packet to do. Packet tracer to do. Go back and look. Right here. 2.411, 266. All right. Any questions so far? Does this help y'all, me going through these commands like this?
Yes.
Yes, okay. Okay, because I thought if we talked about it and you saw it here, that would probably help you a little bit. Propagated default static route in OSPF. So what do we remember about a default static route? What do we remember about that? So static route, something we put in. We're going to tell it to go this way, where what we've been talking about, these are dynamic routes. Dynamic routes, it can change. And remember OSPF, it had an AD of 110. A static route is something that I put in, and well, an administrator puts in. Administrator put a static route in, like this right here. You know, this is a static route to go to the internet. I mean, what other ways can you go to the internet? You can't. So this is the static route to the internet. So you make this a default static route where static route, this is where I'm going to go. And default is if I don't find any other thing, you know, I go down my list, I don't see it, don't see it, don't see it, don't see it. Okay, let's go to default. Boom. That's where we're going to go. Do you remember how we saw a default static? Well, let's start first with a static. You remember how we saw a static on Legend if we did a show IP route? What that showed up as? Like OSPF showed up as an O. RIPS showed up as a R. What does static show up as?
An S.
An S, that's right. So if you see a S, you know it's static. And on IPv4, how do we know it's a default? There was a symbol there. You remember the symbol next to it?
The star.
Star symbol, exactly. You had that little star symbol there. What's the administrative distance for a static address or static route?
1.
1. That's exactly right. So when it's going down the routing table, if it comes to OSPF and it goes to in a static route, and the way we want to go, which one is it going to pick? It's going to pick that static route because it has a lower AD. Okay. So how do we set up a static route? Right here, IP route 000, subnet mask is all zeros, and it's the next hop address. So there's two ways we can do it. We can put next hop address, or we can put the exit interface. You can put either one of those. Okay, either one of those you can put in there. What else here? All right, verifying, you know, we're doing that show IP route. There it is, show IP route is again. And we can see here, there's our S, and it's for a static route. And our star sign is our default. There's our zeros, and it's tied back in the example up here to loop back 1. You can see here that looking at router 1 here, we see our static. Let me back up. This is our default route, but it used OSPF to calculate that. Okay, it calculates it. See right here, it's signifying that it learned using OSPF. So it learned that default route by OSPF. So if you see, that's your default right there. And it learned it by OSPF, that route. And you can see the static, and you notice here it's 110. That's why it's 110, because it's OSPF. And last but not least, what's the difference here? Default OSPF, learned it that way. Okay, that's it. Okay. Oh, let me point out this since I just saw this too. So what did the C mean? Remember what that C meant?
Directly connected.
Yes, directly connected. It's directly connected, and that's the network. And the L, it'll always have the /32. This is the gateway address right here. That's the gateway address. Okay, and 253, I didn't set that one up to do. Don't need to worry about that one. And then verifying OSPF neighbors, seeing who's adjacent to you, that kind of stuff going on. OSP neighbor, there's the command. Anytime, again, I hate to go back, anytime you're doing verify or anything like that, you're doing a show command here. So you can see your neighbor, your routing ID, what state it's in, full, what it is, your dead timer here, how much time's remaining, your address, and the interface it's going out on. Your protocols, if you show IP protocols, it'll tell you that here you're using OSPF. There's your ID you set up as 10. There's your router ID. And you can see the networks that OSPF is connected to. And your default AD is 110. That's just OSPF. Processes. So IP process, different thing. Here's your router ID. You can see various things that are in there. What area it's in. Area 0. Backbone, I think we used that term last Tuesday, the backbone, where area 0 is like the backbone, and I can have other areas. And if I have other areas, I have to have a router that's in this backbone area 0, that has one interface in this, and I can have another interface out in that other one, out into that other area. Again, just verifying different things about it. Okay, I'm not going to type all these summary commands here, or show commands. So yeah, I think the lab will have you go through and verify it with your labs and stuff. So we're in here. So yeah, so this one's part of it. 2.66 verifying single area OSPF. And again, a single area is not, as opposed to a multiple area. This is just that single area. And yeah, 266, you can see it right here. So those are the 3 packet tracers are due Sunday, and this test, and I'll get that thing turned on right here in a minute, and it turns off Sunday as well. All right. So, anybody got any questions?
Mr. Carson?
Yes, sir.
So the test will be available starting today or tomorrow, right?
Oh, it'll be today. As soon as I hang up here, I'm going to enable it.
Okay, sir.
Yep, and it'll be in Cisco Academy, and
Okay, sir.
it'll turn off on Sunday night at midnight. If anybody has any questions or problems, or let me know. So if y'all don't have anything, that's all I have. So I'll get a little time today. Well, y'all enjoy the rest of your day, rest of your classes, and I hope y'all have a great weekend. And if I don't hear from you, we will get together again. What, Tuesday? So have a great weekend. Be careful. Be safe.
You too, Mr. Carson.
All right. See you later.
See ya.
Have a good one.
You too.